Bergson and holographic theory. Continuing, we'll be looking at gyros and the imaginary number I, or shall we say physics versus the gyro, or does math, unreality, create reality? Well, maybe not. I've remarked on the enormous structure of mathematics, constructed over the last few centuries, massive effort of thought. At the structure's core, as we've seen, and now at physics core, in psi, the wave equation, the imaginary numbers. Look to that number 63. The enormous structure is employed with tremendous zeal by physics, biology, cognitive science, neuroscience as an explanatory framework, totally explanatory, but now virtually unquestioned. Its lure as sheer intellectual power remarkable. An army of intellectuals has been and is devoted to it, dwarfing the puny forces of the Bergsonians. But there's that humble thingy, the gyro. In a recent video, Veritasium takes us through the interesting history leading to the discovery of the imaginaries. He opens with this statement. Then came a problem that was considered impossible. The secret to solving it was to separate math from the real world, to split algebra from geometry, and to invent new numbers so fanciful they are called imaginary. Ironically, 400 years later, these very numbers turn up in our best physical theory of the universe. Note, as we looked at the core, e to the I pi, at the wave equation, Feynman, e to the I pi or pi I are joule. And the kicker, only by abandoning mass connection to reality could we discover reality's true nature. So this is the contestant of the current mindset. Our math and our wave equation, psi, is a perfect description of the universe. But Schrödinger didn't think so, certainly. For example, number 60. So let's take a quick peek at the history. Try to go through this as quickly as I can. In 1494, as Veritasium describes things, Luca Pacioli, in his treatise on the then-known math, declared finding a general solution to the cubic equation impossible. 4,000 years of trying had failed. There's a cubic equation there, x to the cube plus bx squared, etc. A bit surprising, because if you take away the x cubed term, we've got a quadratic as such. And the solution had been found many a time. Looks like that. But behind this normally plug-and-play solution equation to the quadratic, there is much geometry. Call it visual reality. For example, there's a quadratic there, x squared plus 26x equals 27. I got an x by x squared, a 13 by x rectangle, another 13 by x, and this square, 13 by 13, 169. So there's the visual reality behind the thing. And the solution to the equation, the square root of 196 equals 14, actually the size of that larger square. But another solution is x equals minus 27. But what is a square that has minus 27 in length? So for thousands of years, mathematicians ignored these negative solutions. In other words, they stayed in physical reality. In 1535, Niccolò Tartaglia was forced to respond to a math throwdown, shall we say, that is, a math duel, to keep his job. His young afflictor, Fior, had been given the secret of solving the depressed cubic by his dying mentor, Tefero. And Fior, who really didn't understand things, gave tons of these to solve, notice, an ambush, to Tartaglia. Depressed cubic, depressing things. We're simply removing the square term, and we've got a depressed cubic. Yep, very depressed. The essence of Tartaglia's approach, who had to reconstruct this on the fly to meet the duel, was again visual reality. Here we have a nice depressed cubic, x cubed plus 9x equals 26. The whole thing is going to be a larger cube than the x cubed in the center, larger by some amount y. X plus y equals z, so we get the whole z, and the larger cube is then parsed into its components. As such, the new components are put together. The volume is now derivable because v equals 3 times yxz. And we reassemble, ta-da, and we have a new expression from which we can solve for x, that is x equal 1. Fior met miserable defeat. Tartaglia became famous. Now Tartaglia confided his secret to Cardano, who later showed algebraically that all cubics can be transformed into depressed cubics. The solution method is good for all cubics. Well, except for a problem. In Cardano's algorithm, he found cases that yield a solution that contain the square root of a negative number. For example, that equation up there, there's a solution that looks like that. We've got the square root of minus 21, minus 121. Re-examining, he sees that the final quadratic, completing the square step, leads to a geometric paradox. He finds a part of the square that must have an area of 30, but sides of length 5. Otherwise, it should be 5 by 5, 25, but it's 30. The full square must have an area of 25. To complete the square, he must somehow add negative area. But this is where the square roots of negatives comes from. But this was taken as math's way of saying, or telling you, there is no actual solution. Yet, this equation has a solution, x equals 4. Cardano was stumped. 10 years later, Bombelli took the step. Bombelli, the square roots of negatives, quote, cannot be called either positive or negative. The terms in Cardano's solution could be represented as some combination or an ordinary number, a, and this new type of number, call it b times the square root of minus 1. This algebra works perfectly. Cardano's weird equation is solved. It has a cube root of 4. But this is done only by abandoning the geometry in the very proof that got us going. Descartes made heavy use of these, calling them imaginary, and the name stuck. Euler encoded this as I, the imaginary number. In other words, we become quite comfortable with this. Which brings us to the point. Veritasium taking us to Schrödinger. Physicists, he notes, are not comfortable with imaginaries. Schrödinger himself was not, noting, despite the I, that psi must be a real function. Veritasium notes that I has this interesting property. It is imaginary numbers exist on a dimension perpendicular to the real number line. So we have the real number line going horizontal, the imaginary number line vertical perpendicular. Together they form the complex plane. When we repeatedly multiply by I, starting with 1 times I equal minus I, equal 1 I, and then I times I equals minus 1, and then the square root of minus 1 times square root of minus 1 equals minus 1 by definition. Then 1 times I equals minus I, and I minus I times I equal 1. So we're going around the circle. We come back to where we started. It's a rotation by 90 degrees in the complex plane. As such, a function that repeatedly multiplies by I as you go down the axis is the one we started showing the first slide, e to the ix, where we've got the imaginary plane and our sines and cosines rotating, as it were. This creates a spiral by spreading out these rotations all along the x-axis. The real part of this is a cosine wave. The imaginary part is a sine wave. So Freeman-Dyson stated, Schrödinger put the square root of minus 1 into the equation, and suddenly it made sense. Suddenly it became a wave equation instead of a heat conduction equation. And Schrödinger found to his delight that the equation has a solution corresponding to the quantized orbits in the Bohr model of the atom. It turns out that Schrödinger's equation describes correctly everything we know about the behavior of atoms. It is the basis of all chemistry and most of physics. And that square root of -1 means that nature works with complex numbers and not with real numbers. This discovery came as a complete surprise to Schrödinger as well as everyone else. And then Bergson says, only by giving up mass connection to reality could it guide us to the deeper truth about the way the universe works. And that's the current mindset. But this statement describes correctly everything we know. Schrödinger disputed this wholeheartedly and refuted this, as we saw in number 60. So, are complex numbers maybe just hiding physical reality? Which brings us to Dr. Lathwaite, known as the father of maglev. He devised a technology. Britain actually halted his project. Germany and Japan knew better, as we've seen. Lathwaite is famous, or perhaps should be, for his lectures and demos of gyros. Famous lecture, The Jabberwock, given in 1974 at the Royal Institute. In this lecture, for example, he shows an extremely heavy gyro, about 50 pounds, on a hinge, being spun up. There's the hinge being spun up there with like a drill, and now it's simply floating in the horizontal plane on the hinge as it spins and precesses around the post. Another demonstration, we have a gyro happily precessing long after the platform is extended past its tipping point. So that metal platform is way past its tipping point, but it keeps right on precessing. But there's the kind of weight necessary once the gyro is stopped to actually keep the platform down. So somehow that much weight is being offset simply by the precessing gyro. How? But back to it spinning. Who needs weight? Why? The audience is in rapt attention, total attention. Something is going on, something we don't understand, but what? Well, warning, we're not going to understand either, but it raises a bit of a question about the complex numbers, the status of psi, and our physics. Lathwaite builds an argument that the rules for the action of gyros are analogous to electromagnetisms. For example, Fleming's left-hand rule for direction of current flow, the field, the motion, etc. This is found in two spots. The second, first let me start there, is in this article, Electromagnetic Phenomena. The bigger they are, the harder they fall, and this chapter 4 titled The Jabberwock. The second, this chapter 4, is an expanded version of the first, with the analogy built there. Note, this is the action of a mechanical device, Newtonian mechanical, yet acting analogously, he thinks, to electromagnetism. So this is not good old Newtonian mechanics. Let's go immediately to what caught my attention, really, are fun imaginary numbers. So he talks about Ohm's law. The current through a conductor between 2 points is directly proportional to the voltage across the 2 points. So we've got the 2 points there, the voltage V plus or minus the 2 points, and in the middle, of course, there's some resistance. The resistance of the conductor is the constant of proportionality. And so given the resistance R as a constant, as the voltage grows, so does the current I, proportionally. So I is proportional to V over R. Or we can substitute E as for V as electric voltage, as Lathwaite tends to do. We'll do that now. Or E equals Ri. So I is the current through the conductor, V the electromotive force, the voltage measured across the conductor. So it's force, analogously to Newtonian physics. R is the resistance of the conductor. Nice, except this only holds for a current of constant velocity. If the current is changing, accelerating, it doesn't work. This problem was seen after Faraday's work on electromagnetic induction in 1831. or passing a magnet through a coil, getting some voltage. So another look at it, same thing. Start the current, induce current on this side. The modification was expressed as Dr. L states it, as such. So we had e to the e equal ri up there, but we're adding this term. Where L is the inductance value, and di over dt is the change of current I over the change in time, dt. So now we're bringing in the dynamics of the field. So he notes Ohm's law is never said to be wrong. It holds for direct current, but for alternating current, where you've got that time change, it is extended by using the idea of a voltage wave that leads the current wave by 90 degrees. So over on the right, I'm giving a little picture there that one can pick out of Google Images. There we see the current, or the voltage wave V in blue leading the current wave I, and the red wave, and they can be treated as an angle, an angular difference, VI, with angle being theta or phi. Again, another picture of it. So again, I'm going to repeat that. By using the idea of a voltage wave that leads the current wave by 90 degrees, giving a net value of power over a complete cycle of events equal to 0. He says wattless current, a term now frowned upon in favor of reactive volt amperes, remained a mystery for many electricians in this century. Wattless current, what's that? Well, the component of the AC current that consumes 0 power in a circuit is known as wattless current. The average power dissipated in an AC circuit is given by the equation P equals VI, the voltage, cosine theta. So again, that's cosine theta is expressive of the phase difference. If you look down of the two waves, look down the right bottom right quadrant of the white there, you'll see the angular difference. You're going to get the cosine of that angle between the two waves. In a circuit that contains only a capacitor or inductor, the phase difference between the voltage and the current is pi over 2. Therefore, cosine theta becomes 0, and the power dissipated will be 0. That is, no power dissipation in spite of the current flowing. So current with no power dissipation equals wattless current. Now that's now called, as Dr. L notes, reactive volt amperes. Well, I won't say now because it's sitting right there in the wiki. So it was supposed to be helpful to write a reactance, that is this wattless current, reactive volt amperes, as J, L the inductance, and omega, the angle, where J equals what? There we are, the square root of -1. In other words, we're bringing in the imaginary number. Yet everyone knows there's no real number which multiplied by itself gives -1. Again, he knows reactance. Reactance is the resistance in the AC context. The opposition presented to alternating current by inductance, cell, or capacitance. Both in capacitance and inductance come in here either way. Omega is the angular frequency of the alternating current. So he says this: it was a cover-up for a new concept. It was recognition that magnetism was tied to electricity, which later, via Maxwell, as we'll see, was said to occur through, and sometimes hard to read that text, but I think through another dimension. And he notes, the engineer, of course, was satisfied with mu0 as the magic door. Now, what's mu0? Well, we're looking at Max. Remember, he said we're bringing in Maxwell. So we have Maxwell's equations. mu0 is the magic door through which one could pass from what had been one discipline in electricity to another, magnetism. Note he uses the term magic door. So in those equations, we have the magnetic field, B, and we have mu0 there. What's mu0? Well, it's the permeability of free space. That is the magnetic permeability in a classical vacuum, the ability of a current to create a magnetic field. Nice concept. And then E0 is the permittivity of free space. And then, I forgot the note, C is the speed of light is equal to 1 over the square root of E0 mu0. So Dr. L's point was the massive conceptual change that was required embodied there in Maxwell's equations, none of which was captured by the J-L omega, where the J is the engineer's I. So you had a rather huge conceptual change, all of which is being hidden by an imaginary number. It's interesting to ask, what happened to this? That is the speed of light. That is the ratio of two constants, two properties of the ether, the E0 and the mu0. Though they state now that mu0 is experimentally determined. Interesting. So was it really that easy just to declare C a constant, the ether non-existent, and E0 mu0 basically useful fictions, C being a constant speed of light? Yet I just watched this morning Unzicker's Real Physics, noting that Einstein reversed himself in general relativity and started touting that speed of light is very well, that general relativity is based on that. The absolute pile of contradictions in special relativity and general relativity blow your mind, but anyhow. Dr. L drew an analogy from the realm of electromagnetism and Ohm's law to the very Newtonian mechanical realm of the gyro. It's far from the explanation truly needed for the whole thing, but it's only analogous to Faraday's generalization of Ohm, in my opinion, not to the move from Faraday to Maxwell. It's as such. On the EM side, we have Ohm's law, and then Ohm expanded with inductance L and the current change di over dt. On the Newtonian side, we have momentum equals mass times force. Now, he put force there rather than velocity, and I'm not clear why. Perhaps people can tell me in the comments, but we'll go with this. So, expanded, we add another term, intractance A, and the change of force, dF dt, where dF dt has been called surge, or the change of acceleration. And A is analogous to like reactance, that is the reluctance for things to get going. Why that additional term? Well, here we have the gyro spun up on its horizontal axis. The finger is attempting to turn it on its vertical axis, so it resists efforts to turn it around its vertical axis. Instead, it precesses on axis omega, that is, it has a moment of inertia, I, on the vertical axis, and an apparent angular velocity about the precession axis, omega. Thus, an apparent momentum, I omega. The momentum is apparent. Why? Because it takes barely a touch with the finger to stop it, as Dr. L emphasizes. Almost nothing in the sense of actual momentum shows it. Well, nothing is apparent. It's like the reactive volt amps. It is apparent power, wattless current. The rotational speed about the horizontal axis, little omega, required to reduce precessional speed, omega is, here's the equation, where we have mass, force of gravity, the reactance, and I over I times I omega, that apparent momentum. Now extend the platform past its tipping point. He says we must at least conclude that a precessing gyro displays neither angular momentum nor centrifugal force, because it simply isn't flying off either, about its precession axis. And however distasteful, we have to go on to accept that we need an additional sheet anchor, the concept, on which to cling if we are to handle the inertial equivalent of alternating currents. As he says, for a gyro in precession is unique in being the only object known to us that will exhibit continuous rate of change of acceleration. If one looks at Wiki, one would think the thoughts we've seen have been debunked. The Royal Institute rejected Dr. L's 1974 talk. His nomination to the Royal Institute blocked. Wiki references this video over on the right, describing Dr. L's ostracization and his continued efforts to understand what is going on with the gyros. In the video, he tests, standing on a scale, whirling the 50-plus pound gyro overhead with one hand to see if there's a measurable weight loss. Because you just can't pick that gyro up on that long pole and swing it around. It's just way too heavy. But there he is, just swinging it around like nothing. There are strange fluctuations of the weight, but somewhere along the line they're just discarded in the video. Dr. L comes to these conclusions. A precessing gyro, this is after many years, a precessing gyro can move mass through space. If the gyro does not produce the full amount of centrifugal force on its pivot in the center, and it doesn't, the full amount of centrifugal force doesn't fly off, and it doesn't, then indeed you have produced mass transfer. So, but when we look at that, we've got the weight there required when the gyro is stopped to keep it from tipping. The gyro spinning happily doesn't need the weight. So really, this is just mass transfer. Just to where is the gyro transferring its mass, such that the platform stays down? And how? See, this really doesn't make sense. I'm just going to throw in again, I think this kind of problem is related. Scientific American. Suddenly we're realizing the theory of lift via ring form is dead. Miles Mathis, I noted, thought lift might be via the rising charge field of the Earth. The wings in motion gather charge. The greater velocity of the wings moving through the charge field, the more charge is picked up. With respect to a spinning gyro, he wondered if the same principle holds. Possible. And Dr. L concludes, and this is of course Wiki's notion that it's all debunked, gyroscopes behave absolutely in accord with Newton's laws. Except that's hardly an explanation, is it? No proof of how the mathematics works, the Newtonian laws, is given. And one comes away with the distinct impression that Dr. L gave in to severe psychological pressure to re-achieve acceptance in the orthodox science world. And nowhere is this statement of Dr. L resolved. Of all the critics I showed lifting the big wheel, none of them ever tried to explain it to me. The video had at least one physicist intoning that no problem, Newtonian mechanics explains everything. Right. Is this all the realm of least action? Given the proper form of swivel, one could imagine a setup where you would simply drop an unspun gyro and it just act like a pendulum, swing back and forth. We're then in the realm of least action, the Lagrangian, as we discussed. The Lagrangian describing the paths of objects, supposedly minimizing the relation between potential energy and kinetic energy. We saw Sabina's problem with all this. The path is a future integral. We're integrating from TA to TB to the future. How does the object know the path? Good question. The problem source, as I noted, the path is only a mathematical description. This is all a mathematical description that was born with Euler, Lagrange, Bernoulli, etc. Not a physical explanation, not a physical model. That is, not a model of the object's interaction with an ether medium, for example, in which it is embedded, where in fact the object is in essence only a vortex in the ether. So you can imagine how important it would be to understand the actual interaction of a quote object unquote in the ether. That would be the source of how it moves. Spin up the gyro. Now drop it on its hidden swivel. It's hardly now the path of least action. Why? It's only a pendulum that happens to be spinning. Why the difference? If we could drop it before as a pendulum unspinning, then why can't we drop it again with it spinning? What's the difference? Newton's laws in electromagnetism, as Sabina pointed out, even Maxwell's equations, are least action laws. Can the math of least action explain this path? Is the gyro seeing this future? Really? So why the Jabberwock? There's an obvious allusion from the poem. 'Twas brilliant in the slatty toves, the gyre and gimbal in the wabe. So the gyro and its gimbal, which Dr. L invites us, or says Carroll's invited us to consider that perhaps the implication of the gyro. But there's more going on. Lewis Carroll, aka Charles Dodson, 1832 to 1898, was a very good mathematician. Alice in Wonderland, as well as the Jabberwocky, were his subtle shots at what he saw as the development of unreal absurdities in mathematics, an ongoing disconnect from reality. Just one example. In the Tea Party, the Dormouse, the Mad Hatter, and the March Hare are all going in a circle around the table in a perpetual tea time, as Carroll took away the fourth member of their party, time. This is taken to be a shot at Hamilton's quaternions, a sort of coordinate system based on four terms, three that designate place or spatial dimensions, as our abstract continuum of points, positions, and one that designated, or so Hamilton decided, time. With these four terms, Hamilton could describe rotation in a three-dimensional universe. He could only do this, though, if he added that fourth component. Without time, they would keep rotating around and around in a plane, like the hands of a clock. So instead, they rotate round and around, coming back to the same point, essentially, with an abstract spatial dimension called time. For Carroll, you don't simply appropriate time as a fourth spatial dimension. By taking away time, you left the other three to keep going around in circles forever, like an incomplete quaternion. Now, this is all dismissed as, quote, Carroll's way of belittling and perhaps even maintaining equilibrium, I guess his own psychological equilibrium, in the face of dramatic change. Of course, neglecting the possibility that he might be right. Physics is now based in these mathematical developments, largely based. The heart of which, the imaginary I, in Euler's identity, e to the pi I equals 0. I've only pecked at a few of those supports holding up that house of explanation. Early in his talk, Dr. L gave a demo. In 1830, a coil of wire was supposed to have a property all its own, resistance. measured via the ratio of the voltage across it to the current flowing in, as we saw in the little diagram up to the left. He passes some direct current into the coil, 5 amps. And the second coil only connected to the voltmeter. It gets some induced voltage. There we see 2 volts in that second coil. And he says, it gets this induced voltage by a mechanism I do not understand, nor do I suspect does anyone else. In other words, a mystery. Now, turn that second coil, turn it 90 degrees. And he says, you always find a place where the voltage is 0. Still reading 0 there now. It's as if they live in separate worlds and didn't want to know about each other. So he's pointing to a mystery. Now, Bob Shaw, my PhD thesis advisor and Gibson student, founder of the Journal of Ecological Psychology, taught us the importance of demonstrations. They're like use cases when building a system. You cannot ignore them when designing a system. You have to incorporate them, cover them. These are demonstrations. This gyro hanging on its platform, happily processing. Or, as we talked about before, this rotating cube while being strobed. Rigid when strobed in phase with its symmetry period, non-rigid, plastically deforming when out of phase of the symmetry period, symmetry being 4. In other words, form, perceived form as a function of discrete sampling, not possible. One has to incorporate this. So they tell us, particularly in the physics case, physics' mathematical framework of explanation, quote unquote, is not even close. Physics, its mathematical explanation form, is trying to stuff all phenomena into a closed box. What can be termed in a predicative whole, which we have to talk about some other time, constructed on the basis of a discrete 0 time. So everything fits in that nice little rotating clock coming always back to 0. Electromagnetism is far deeper than understood. In other words, the deep structure and dynamics of the matter field is far from understood. Current physics is not even close to the starting point required for a theory of consciousness. It cannot be the base for a theory of consciousness. So next we'll see. Till then, signing off.